In modern software development, speed is everything. We deploy faster and rely on automation, especially AI-powered UI testing, to keep up. These tools promise self-healing, tests that adapt to minor UI changes, reducing maintenance headaches. But this convenience hides a risk. The same intelligence that finds a moved button can also miss why it moved, undermining the rigor of A/B and multivariate testing. Let's unpack how self-healing works, why it clashes with A/B testing, and how to use AI in testing wisely. The goal isn't to condemn AI, but to understand its limits and wield it with precision. If we can't trust our experiments, we're flying blind, making decisions on guesswork, not evidence. We must build a testing strategy that's robust, efficient, and honest, so our quest for speed doesn't lead to self-deception. Self-healing automation tackles a classic QA pain-fragile tests that break with every UI tweak. Traditional scripts rely on hard-coded locators, change an ID and the test fails even if the app works fine. Self-healing uses AI to find elements by text, position, or appearance, adapting to superficial changes. This resilience slashes maintenance, speeds up feedback, and boosts developer productivity. Teams can trust their automation suite again, using it as a true quality gate instead of a noisy, unreliable system. Self-healing also lowers the barrier for non-technical team members to contribute tests, embedding quality deeper into the culture. In short, self-healing makes UI automation what it should be: reliable, efficient, and scalable for high-velocity teams. A/B testing is the scientific method for product development. Does one change impact user behavior? We split users between a control, A, and a variant, B, measuring results with strict control over variables. The only difference between groups must be the change we're testing. Any other factor contaminates the results. Multivariate testing ups the ante, testing multiple changes and their interactions, demanding even more discipline. The foundation is certainty, knowing exactly which version each user sees, with flawless tracking and data logging. If users see the wrong variant, their data becomes noise, weakening the experiment. That's why experimentation platforms are built for precision and consistency. Self-healing automation and A/B testing have opposing goals: adaptability versus strict control. In A/B tests, we must verify a specific variant. Self-healing, however, adapts to find equivalent elements, even if they belong to the wrong variant. Imagine a test for a blue sign-up button, variant A. If the environment serves the green button, variant B, a traditional test fails, alerting us to the problem. With self-healing, the AI finds the green button, clicks it, and the test passes, falsely reporting success for variant A. This contaminates experimental data, blending results and making outcomes untrustworthy. The problem worsens with subtle changes, like reordered links or tweaked tooltips, where self-healing scripts adapt and mask variant delivery errors. The result: silent corruption of experiment results, leading teams to make decisions on phantom data. Despite risks, self-healing automation is invaluable, if used wisely. Apply it to stable, shared UI components not involved in experiments like navigation headers or account settings. Here, self-healing adapts to harmless refactors, confirming core functionality without risking experimental data. It's also perfect for early feature development, where the UI is in flux and brittle tests would be a maintenance nightmare. For infrastructure and smoke tests, where the goal is to check basic app health, self-healing's adaptability is exactly what's needed. In these contexts, AI-powered resilience aligns perfectly with test intent. To automate A/B test verification safely, shift from "does the flow work" to "is the correct variant displayed and working?" Use strict non-healing selectors for experimental elements. Tests should fail if the exact variant isn't found. Start each test with an explicit variant check. Assert unique identifiers or experiment flags before interacting. If the wrong variant is served, fail fast and clearly. Maintain isolated, stable test data. Each run should use a clean user profile to avoid cross-contamination. Detailed logging is essential. record which script ran, which variant was tested, and capture screenshots or DOM snapshots. This transparency makes diagnosing failures straightforward and preserves experiment integrity. The best automation strategy isn't all or nothing. It's a hybrid of strictness and flexibility. Use strict scripts for experiments, self-healing for regression and smoke tests. Architect your framework for granular control, enable or disable self-healing per test or element. For example, use a hard-coded selector for an A/B tested button, but self-healing for the rest of the checkout flow. Tag tests as experiment or regression, so the engine applies the right policy automatically. This systematic approach embeds discipline, turning self-healing from a liability into a powerful, context-aware tool. By distinguishing between tests for scientific rigor and those for regression coverage, you maximize speed and safeguard data-driven decisions. Hybrid automation needs tools that are both powerful and flexible, like Omniit.ai. Omniit.ai gives engineers granular control, letting them set healing policies per suite or interaction. For A/B tests, strict policies disable adaptive locators, ensuring tests fail if the wrong variant appears. For regression, adaptive policies absorb minor UI changes, reducing maintenance. Omniit.ai also offers advanced visual validation, asserting not just element presence but correct color, size, and placement. This visual-first approach catches subtle bugs and ensures the right user experience. As automation and experimentation become more intertwined, tools like Omniit.ai help teams move fast and make decisions with confidence, backed by clean, trustworthy data.